Greetings again everyone, welcome back to my channel. Here we have another algebraic exponential equation that we're going to solve. In this equation we're going to find x, where we have 4 to the power of negative x is equal to x. Now you may want to pause this video and see if you can do this one by yourself. You may also check out my playlist on how to solve mathematical equations like these ones. Okay, let us look at our solution. So here we said that we have an equation such as 4 to the power of negative x, and this is equal to x. We start by bringing the x on one side of this equation. And we start to do that by looking at our law of indices here, where we have 4 to the power of negative x. It's the same as saying a to the power of negative 1 is equal to 1 over a. So we rewrite 4 to the power of negative x in this way. So then we have 1 over 4 to the power of x, and this is equal to x. So as we said that we are going to bring the x on one side of this equation, this means from here we multiply both sides of this equation by 4 to the power of x. This means that on the left we have 4 to the power of x times 1 over 4 to the power of x, and on the right we have x times 4 to the power of x. On the left, we cancel out 4 to the power of x, and that remains us with 1. And on the right we have x times 4 to the power of x. So now we have x on one side of this equation. And so from here I'll be introducing my method in solving this equation. And this method is the Lambert W function. Now this is a very special type of function that is used to solve the equation where we have the variable in the base and also in the power. In this case x is in the base, which is x times 4. And x being in the power as 4 being raised to the power of x. Now how this function works is that if we have an expression such as a times e to the power of a, if we apply a w function to this expression, our result is a. So then for this function to work, we have to have an expression such as a times e to the power of a. Here in this equation we have a here in the base and a in the power. But what we don't have is an e here. What happens is that we have a 4 instead of an e. So we need to write this 4 in terms of e. Now 4 can be written in the form of e by having e to the power of ln 4. The idea here is that ln means natural log, where the base is e. So what we're saying is that we have e to the power of log base e of 4. And here the base e is going to cancel out the log base e. So these two, they are going to be cancelled out and the result is just 4. So therefore we can rewrite 4 in the form of e to the power of ln 4. So by rewriting our equation, rewriting 4 in terms of e. So we said that we have 1 is equal to x times, and rewriting 4 in the form of e, we have e to the power of ln 4. We bracket this expression as this is just 4 and this is powered by x. Now understanding laws of indices, we know that a to the power of n in brackets powered by m is the same as just multiplying the power. So a to the power of n times m. So we rewrite our equation with this understanding. So we say that 1 is equal to x times e to the power of x ln 4. Now looking at our equation, we see where we have x and in the power we have x ln 4. This means that we know to apply this w function, we must have a in the base to apply this w function. We quickly resolve this issue by multiplying both sides of this equation by ln 4. So we have ln 4 times 1 is equal to x times e to the power of x ln 4 in brackets times ln 4. And so this will resolve our issue of the x ln 4 in the power. And as we know, 1 times anything is just itself. And since multiplication is commutative, we can write this in any order. So we have x ln 4 times e to the power of x ln 4. Now looking at our expression here, we have x times ln 4 times e to the power of x ln 4. This means that we have the same value in the power and also in the base. So we have a in the power and a in the base, and in the middle we have e. Now what we're saying, if we apply a w function to this equation, so we have w of ln 4 and w to this expression here, which is a times e to the power of a. Applying a w function to that expression gives us the value of a. So we rewrite this equation, so we have w of ln 4 is equal to a, which is x ln 4. So we said that we have w of ln 4, and we said that that is equal to x ln 4, the value of a. Now from here we solve x by dividing both sides of this equation by ln 4. So W of ln 4 over ln 4, and on the right the ln 4's are going to be cancelled out, so that's just going to leave us with x. And so now we have W of ln 4 over ln 4 is equal to x. Now if we plug this into Wolfram Alpha, which is our calculating tool, so if we plug that in and then we scroll down, we see our input and we see the decimal form of this input, which is 0.5. So using our calculating tool, we see that x is equal to 0.5, or we could say that x is equal to a half. Now we can verify this solution. So let's go ahead and verify our solution for x. So we said that x is equal to 0.5 or a half. So we'll be using a half for this exercise. And we'll be doing this by rewriting our original equation. So we said that we have 4 to the power of x is equal to x. And so we know that x is equal to half, so we just plug that in. So we'll say that 4 to the power of negative a half is equal to a half. And now from here, as we have 4 to the power of negative the value of x, which is a half, we rewrite this using our law of indices here that we looked at earlier. And so applying that rule again here, we have 1 over 4 to the power of a half. So this should be 1 over 2. And of course, this is equal to a half, 1 over 2. Now we know that when we have a fraction, the denominator represents the root. So in this case, we have the square root of 4. And so this is equal to a half. And what is the square root of 4? We know that the square root of 4 is 2. So this is 1 over 2 is equal to a half. And so there we have it. A half is equal to a half. And so we know that this is correct. And our solution of x is therefore true. X is indeed equal to a half, or 0.5. Now thanks again for staying tuned with me to the end of this video. I hope that this was very informative. Please remember to smash that like button, share and subscribe to my channel. And I hope that I will see you again in my next video. Please stay tuned for my newest updates as I continue to share my knowledge in how to solve mathematical equations like these ones. So thanks again for watching, and I'll hope to see you again in my next videos. Until then, take care. I'll see you soon.